This conference will now be recorded.
Okay, let's see. 3 items on the agenda today. Happy Friday, everyone. One, we've got some exciting progress on the POC to report. And then Vijay is online. Vijay, I saw you. You're here, right? Yeah.
Yes, JP. Yes, Bobby. Sorry.
And then we've got Jawad and David with a discussion about the CDX white paper, and I'm looking for volunteers. And finally, I want to have a discussion about, if we have some time, about who else we can sort of bring into the agenda in the future. That's basically it. Does anybody have any big opens before we go to these two? Okay, I'll do a poll. So Suresh, Vijay, it's all yours. I'm going to stop sharing and oops.
Thank you, JP. Bobby.
We've got wiggling bits, so.
Bobby, are you able to see the presentation?
Yeah. So by way of a reminder, Vijay and Shakti are with Tamand, and the POC, JP leads the POC implementation effort. We've had 3 boards, and he'll go through that, but Vijay, go ahead, please. Sorry.
Thank you, Bobby. Thank you for the introduction. Hello, everyone. This is Vijay and Shakti here. We work for a small startup called Tamand. We have been assigned the job of developing the designing and developing the Accelerator platform, the test platform. So we have the platform and the interposer card developed for OCP3 NIC. So we'll get in. So I don't know how many of you are familiar with the Mara. We call it the Mara baseboard and the platform effort. So we'll just quickly walk through the agenda. So we're going to be talking about the Accelerator platform overview. And then we have the actual boards that we got at the beginning of this, mid of November, and we have been bringing up the board. So everything is going really well. And then we'll have a quick live demo. And then we'll discuss on the next steps where what needs to be tested and where we are going with the boards. And then we'll give you a quick summary, and then we can go into Q&A. And if anyone has any questions, please feel free to stop us anytime. We can discuss about it. This is actually kind of an overview of the platform. It's an accelerator development platform. OCP, JP came to us and they wanted us to design and develop this platform. So we did a proof of concept platform, I think, beginning of this year. And that doesn't have any connectivity. It was more of a mechanical and physical, a test that we were actually doing with it. Now, this one is a completely functional, designed, completely functional platform with all the components required, and everything is actually working. We've been testing with it. So the concept is to have pitchlets. So this board can actually host 3 pitchlets. They are interconnected between them with PCIe links. And then we have 2 M.2 SSD connectivity. Then we have the power can be fed in. The 3.3 is generated internally, volts that are required for all the different components. And then it has, you can actually control the power. And if you want to change the voltages a bit, we can do that. It's actually a programmable power in it. And then you can actually go into these boards remotely. Using a USB UART. So we have an USB UART setup, and that is actually powered independent of the board. So you'll be able to, exercise a remote execute or whatever you want to do, or even shut down one of the platforms if you have support from that platform. The pitchlet, you can even shut it down and switch it back on through the GPIO control, and that is powered independently through USB. And then we have JTAGs, reset. The PCI H finger, which is number 12, you see in the bottom, gets connected to the host machine. Here, the idea of the host machine is to host a powerful, server that will be running CentOS, and then you will be able to do all your performance testing from it. and that'll be connected through the PCIe edge finger link that you see in the bottom. The board is quite big, and it doesn't comply with the PCIe standards, so you'll not be able to directly insert the board onto the board onto any of the bigger platforms. Although theoretically you could do that, nothing prevents you from doing that, but it's quite heavy and big with all the components in. So we have decided to use a Molex cable. It's a high-end cable that Molex developed for us. A 3M developed for us, that you can actually connect to the PCI interface from the host. Basically all the pitchlets are connected through using Molex Mirrormesh connector. And we also have QSFP connectivity for Ethernet directly into the board. So that's kind of the overview about the board. We'll go into the next.
Hey, Vijay.
Yes.
Okay, I just wanted two things. And JP, you should please step in. One, this is the real board, right? This is no longer like rendering of the board. This is the actual thing. And
no, actually, yeah, this is the actual board. We have a live demo going from it, Bobby, where you can actually log in and see what we have done so far, all the tests, what we have done so far. We have a live demo ready for everyone to see. This is the actual board.
And the second thing is, I think it doesn't say here, but this is a collaboration from fairly astonishing number of companies. I mean, it's been slower than we'd like, but it's been a real across JP from Cisco, Molex, and then Broadcom, NXP, Samsung. There's a whole host of companies involved. And with
we are coming there, JP. Actually, Bapi, we have different. I mean, we have a slide with the different modules that we have to actually briefly talk about them.
Quick question. This looks like a miniature OEM module. Is it sort of looks very similar, but it looks, I guess, smaller, right?
The question is, it looks like a small RAM module, you say?
A small OCP accelerator module. It looks as though it's based off that.
Yeah, it is kind of, but it's a it's a full height PCI card. The OEM baseboard is considerably bigger.
Yes, that's right. Yeah, so it's a miniature OEM.
Yeah, it's
I like the idea.
And the second thing is, in general, it's not designed to be that way, but in general, my understanding is OEM generally is a homogeneous design, and this is sort of specifically meant to be a heterogeneous design.
Right. No, the OEM's heterogeneous. Isn't the intention is?
They intended to be, yeah. So.
Yeah. Okay. All right. No, that's good.
Okay. So, if there are no other questions, we can move forward. So, this is actually a fully populated platform that you're seeing here. So we have fans for cooling, and then we have the Broadcom NIC that goes into the pitchlet 1. We actually developed an interposer pitchlet along with the baseboard that the Broadcom NIC 3.0 card will actually seat in. And then we have Lattice pitchlet, which is the management security pitchlet. It actually is an FPGA. And then we have the NXP pitchlet, which is LX2. It's a new processor that they have. They have actually hosted the processor on this pitchlet. And then we have two Samsung M.2 SSDs. We have fans and the fan controllers for cooling. And then on the left, number 6 is the position where you see the USB UART connected, where you could actually control the board and also communicate to any of the 3 modules that are there if they support USB connectivity. UART connectivity, sorry. And then you have the PCI host connectivity in the bottom, where you could see the PCI cable going out. This is kind of the actual physical test bed we have right now that we have set it up.
Vijay, one question.
Yes, go ahead.
Vijay? Yeah, so all these pitchlets, they are connected via PCI Express?
Yes, so they are interconnected via PCIe Gen 4 connection. And also we have other GPIOs and things connected between them. The Samsung SSDs, the 2 SSDs that we have mounted, are connected to pitchlet C via NVMe PCIe connection.
Right. Do you have a block diagram of this, in the sense that how the components are connected via what, and how the QSFP gets connected and all that?
Yes, the OCP webpage, we have uploaded every document we have, right from the design document to schematics. Everything is actually on the OCP page. We can actually send you a pointer where you can actually have a look at it.
Yeah, that would be great. Thank you.
This whole board is an open source board, so we'll also be uploading the final design, including the layout for anybody to actually review.
Sorry, who was asking the question?
Oh, this is Shreyas.
Hey, Shreyas.
Yeah.
JP can give you a lot of information about it.
JP is
Thanks.
kind of the overall architect.
Yeah, hi Shresh, this is JP. I'm leading the POC program like Bobby was mentioning, but we'll be happy to share the blog that it's not in this presentation, but we'll share with you the all the collaterals, the blog diagram and the kind of architecture details.
Thank you, JP.
So if there are no other questions, we're moving forward. So these are the four, pitchlets modules that you see on the baseboard right now. The first one is the interposer card. So we developed this so that we can have the standard NIC cards plugged into the interposer card. The interposer card is a pitchlet. So you can actually, right now it's hosting the Broadcom NIC 3.0 pitchlet. So you'll be able to insert it in. It's a 200 gig NIC card that will go on it. And then we have the lattice management and security pitchlet. And then we have the NXP. So the NXP hosts their newer processor, which is a 16-core 872 processor with 8 GB of DDR4 RAM. And it has multiple PCIe interfaces and Ethernet ports. So that's hosted on pitchlet C. So all the pitchlets are right now populated. There are no other any other questions. We'll move on to the next one. So this is kind of the server host setup that we did locally. We were planning to use a larger server for testing, and Supermicro is going to supply us the server, and they're going to be hosting it in the future. But in order to just do our testing in our lab, we actually put together a small server host testbed. This consists of a 12-core AMD Ryzen processor with 30 GB of DDR RAM. And then that particular processor supports PCIe Gen 4, two 16x16 slots of PCIe Gen 4. So since we're going to be using the cable from Molex, about 18 inches, 3M, it's about 18 inches of cable that will be connecting the Mara baseboard to the host server. We have actually got a retimer card from Astro Labs. They are the market leader producing retimer cards. So they are a startup actually, and they're doing really well. So they've given us the retimer card, which we have actually put on the host server, and through the 3M cable we are connected to the baseboard, and the host server is running CentOS 8.2. And you could see on the top is where we have actually the processor, and then we have the retimer card. What you see on the bottom is the retimer card with the cable, 3M cable going off of the retimer card. So the retimer card plugs into the baseboard, and then it goes to the the server PCIe X16 slot, and then it goes to the baseboard. And it's an X16 Gen 4 retimer card, to be clear. So if there are no other questions, we'll move on to the next slide. So this is the complete testbed setup. So what you see is the host server, and then you have the 3M cable going in. Then we have all the three pitchlets populated, and then we have a Ethernet loopback, 100 gig Ethernet loopback on the Broadcom card to run a quick loopback test using iPerf. And we have the fans and everything right now powered up with the USB serial that we can actually get in. So this is the setup that we are using to test the pitchlet and the baseboard right now. There are no other questions. We're moving to the next one. So where are we with the Bringup process? So initially we were able to get the, a Broadcom NIC card detected by the AMD server host, and we verified it through the LSPCIe command. And then we had the NIC performance and functionality tested successfully with the iPerf. iPerf is it's a test software that is written in Linux to test the network interfaces on your card. So we were able to use that performance tool to test the connectivity and also the performance of the connection on the ports. And then we have the NXP pitchlet, NXP LX2 pitchlet powered up, and it was functional. It was able to, we were able to download and install Linux, and then it booted up to Linux. Through USB UART, you are able to get into the through the console or the baseboard into the pitchlet, and we are able to completely control it, log in and do all the activities we need to do to control it. And then from there, we were able to execute the NVMe CLI to verify that the M.2 SSDs are seen and accessible at the Ubuntu Linux running in NXP LX2. That's where we are. And then the other task we just did a small software development so that we could actually do remote monitoring and control using Python CLI. So we developed the CLI. It's close to about 400 lines of code. It's actually a library. Right now, we've just modified it a little bit to make it an executable, but it's an open source library. We'll be opening it up. You'll be able to just modify a little bit and then use it in your own script if you want to source it as a library, and then you'll be able to control the board from there. So there are basic functionality, like you can look at the status. You can actually do the, there are about 8 GPIOs connected to all the three pitchlets, and you'll be able to, change the GPIO states. And you can also issue a remote reset where you can actually reset all the platforms remotely. You don't have to be present to actually do that. And then it also will give you some status about the 3.3 power supply and if the PCIe host is connected or not, and some basic information will be available. So that should be more than enough to actually look at the status of the system and control the system remotely using the Python CLI that we have developed. So this is where we are now with the Bringup process. So if there are no questions, we'll go on to the next one. So we're going to have a quick live demo where we are going to demonstrate the different tests we have done. So you could actually make sure that these are actual, tests and really running on the board. So the first live demo is going to contain where you have the CentOS 8.2, and then we have the Astrolabs PCIe Astrolab retimer connected through the cable to the Mara baseboard, which is hosting the interposer card. The interposer card hosts Broadcom card, and there's a 100 gig loop back, and then it comes back. So we're going to run an iPerf command, and then you'll be able to look at the performance. I'll hand it over to Shakti, who's going to quickly run the demo. I hope everyone is able to see the platform. So you could actually see the platform live here. So here's the AMD server running, and then we have the Mara baseboard, which is connected through the USB UART connection, and then you have the Broadcom NIC, and then you have the lattice. You can see the lights blinking, and then this is the NXP pitchlet, which is also connected, and then you have the fans running right now. And then you have the 3M cable that connects to the retimer. So here we have logged into the AMD server, and we have configured the two interfaces. And then you can see there are two interfaces that we have configured. The first two interfaces are the Broadcom interfaces, and we have configured two IP addresses for them. And when you do that, you can see that both the Broadcom interfaces have been recognized, and that's why you're able to see it. And then we're able to do the IP address configuration. And then we can actually run the iPerf command right now. So we have a small script which is called the Ethernet test that Broadcom actually was gracious to give us. So we're going to run this test, which is going to perform the loopback test and it'll tell you what the performance was and how the packets have been sent from one interface to the other. And it goes all the way, like I just explained in the presentation. So you could actually see the test is starting. It's going to be running for 10 seconds one way, and it actually reverses the test. So basically, it goes from Ethernet 0 to Ethernet 1, and then Ethernet 1 to Ethernet 0, confirms the test, and it comes back and tells you what the speed is. Right now, we are achieving about 27.2 gigabits on the line. And you can see the test is passed. So this is a complete loopback test. So this is one demo that we planned for. And going back, if there are any questions, please feel free to stop us. Going back to the presentation, the next. So
Vijay, one second, sorry.
Go ahead, please.
Okay, thanks. Keep going, sorry. No, keep going.
So here are the two LSPCA command we've executed just for illustration purposes. We've captured it in the presentation, so we can use it in the future. So we can see the speed and the bandwidth, and then we have the same test run here. So the next demo we're going to be doing is basically we are running PuTTY on the Linux source machine. We are going to go through the USB UART, and then we are looking at the NXP pitchlet. And then we'll be also looking at, from the NXP pitchlet, we'll be looking at the Samsung M.2 SSDs that are actually right now connected to it. So this is going to be the second demo. And this is kind of the walkthrough, but we'll actually see it in the live demo. So basically, when the NXP pitchlet boots up, you'll be able to see this information. It's going to scroll through really fast. So they have like I think 4 SerDes lanes, which is the X, I think, each one is X8 Gen 3 PCIe SerDes lanes, and then they have a 12-core A72 processor. You can see it on the right. That's running at 700 megahertz. And we also have, it also hosts an 8 GB DDR4 RAM, and you'll be able to boot to Linux. And then they have the sensors command, which actually gives the temperature of the current temperature of the CPU, just to illustrate that it boots up to Ubuntu is where this one is. And then we'll be going to the actual live demo and be looking at it. Yeah, so what you're seeing here is the actual prompt that has come up. We have not yet booted. So what we wanted to also illustrate is you can actually execute a reset from Mara. We'll actually reset it right now, which will actually boot to the SD card. Right. So this is actually through the CLI interface. So it's executed a reset, and you can actually see the NXP card rebooted, and it is actually right now going to come up to Linux prompt. So I've executed the reset through the USB UART interface through the CLI, Python CLI that we have developed. This is actually executed a reset to the entire board, which is resetting the NXP board right now. And it's actually coming up. So all this information that you saw on the previous slide is actually there in this printout, and it scrolls up really fast. That's why we have kind of captured quickly the output. So you're able to log in and get it, and then we'll be able to execute the sensors command. Just booted up. I think it's doing its first operations, taking a bit of time. There you go. So you have the current temperature of the CPU, which is at 49.6 degrees Celsius, and you have the high and the low limits where you'll have issues if it's going to go closer. This is actually developed by NXP to monitor their CPUs remotely. So we're just using that command right now. And then also we have the NVMe command that you can actually execute, where you can see the Samsung interface. So yeah, you can actually see that NXP LX2 is actually recognizing the two Samsung modules that are there. Yeah, you could see the whole. Yeah, so it is a each one is a terabit link, and then you could see all the information that is there. So that is about the NXP Pitchlet Bringup test that we have done. And we'll go switch back to the slides. If you have any questions, please feel free to ask us. Shoot at any time. So this is the command that you saw, and from there you could actually see the Samsung NVMe and M.2 SSDs on the our baseboard, on the NXP Pitchlet, sorry, on the baseboard. And we've also developed the Python CLI for remote management, where you have, to quickly give you a demo, you can actually use Mara, and it'll actually give you all the different options. Oh yeah, let me switch over back to the CLI. Yeah, so when you just execute Mara, right now we've just given the name Mara, so you'll be able to see the different options that are there. You'll be able to see the enumeration. Basically, whenever you actually plug in a USB UART, it randomly picks up different ports. So you just, when you type enumerate, it'll actually give you all the enumerations where you can actually do your, putty kind of log into your module through your USB UART interface. And then you can look at the status, you can do a remote reset, you can actually control the LEDs on them, and you can also, control the, GPIOs executing the command. So if you are actually hooked up one of your power pins to any of these GPIOs, you would be literally able to power cycle your system or your particular pitchlet that you have developed without disturbing any other. Or you could actually execute a master reset, which will actually reset the entire board. Any kind of utility is possible. You just put enumerate, and it'll actually get so it's actually connected from. There are 4 USB UART interfaces from this chip, and 3 of them are actually connected right now, 0, 1, and 2. So it goes 0 goes to the first pitchlet A, pitchlet B, and pitchlet C respectively. So USB 2 would be the one that will be connecting, that we'll be connecting. We were connecting to go into NXP actually, because it's on pitchlet C. And then if you type the status, you'll be able to see the status of the current board right now. So yeah, you'll be able to see the status. The first line, what you see is actually the GPIO value that is being returned by the USB UART. That is for reference, and then you'll be that actually is then enumerated to the value. So the preset is not asserted right now. The 3.3 volt peak good is actually, that means that we are getting that, and the voltage is good in that. And the PCIe host is connected, and all the GPIOs are in high state right now. And then we have 2 LEDs on board just to make sure quickly that we are able to toggle it to see whether the system is actually available. So what you're seeing there, there are 2 LEDs over there, and then you can actually switch on, switch off using the CLI. And you can see the LED is turned off, LED 1 is turned off, and then you can actually turn off LED 2. So both LEDs are turned off. You can turn it back on with an on command. There you go, and then it turns on. So yes, they're both are back on right now. So the LEDs are right here. So that's about the CLI. This is a library. It's an open source. You feel free to. Once we finish up on the project, we'll be publishing it, and then you can actually use it. This also requires a little bit of drivers. So you might have to recompile your driver to support GPIO. Only the latest driver from the latest chip driver on Linux actually supports it, so you might have to compile it. For CentOS 8.2, we do have it. We recommend everyone using CentOS 8.2. The server we'll be hosting in Supermicro moving forward for remote access. We'll be using 8.2, and we'll have taken care of the driver issue that is there. But if you want to use it on your own platform, please contact us and we'll help you build a driver for your platform, and then you'll be able to use the CLI in your platform, other than CentOS 8.2. So if there are any questions, please feel free to shoot. If not, then
Hey, would you go back to that live demo board? I do want to say one important thing.
Sure, Bob. Sure. One second. Yes.
So there are two big things. One, the POC, as Vijay said, Supermicro has volunteered to host this, and so we'll have 2 copies of the baseboard and daughter cards available at for remote access for application development. The second important thing is you can develop your own pitchlet and then reuse any of the existing pitchlets in combination. So if you have an accelerator pitchlet, an FPGA pitchlet, or some other processor pitch or anything you want, all you need to do is follow JP's open specs, and you're in business, and you can leverage this entire infrastructure. So pretty much, hopefully, this gives anybody who wants to develop a new accelerator a leg up, because you've got the CPU, you've got storage, network access, the 3 out of the 4 parts you need. So what we're hoping is, more companies will be interested in developing their own pitchlets for either the processor, accelerators, you name it. And this whole thing is live. So thanks. Thanks, Vijay.
Thank you, Bobby. Thank you very much. So going back to the slides. So this is kind of, again, the capture of the CLI that you have a look at. And then we were looking at this is about the LED demo that we were looking at right now. And then moving forward, there are a few other steps that we need to perform that will validate the hardware before we host it at Supermicro. So regarding the hardware validation, we are looking to complete around January 21st. We have to test the inter-chiplet connectivity test. So it'll be a Broadcom NIC to NXP. That requires a little bit of a hardware change. We are working on the next version of the interposer card that will actually have it. So we should have it by Jan 21st. We should be having that test also done. And then we are going to be doing NXP to NXP PCIe link, Ethernet linked tests. And then we'll be doing the QSFP to NXP pitchlet test. And then we'll be running the NVMe SSD test, M.2 SSD test from the NXP platform, stress testing the 2 Samsung NVMe SSDs that are actually connected to it. And once all these tests are successfully completed, we will be deploying at Supermicro Lab for cloud access, like Bobby mentioned. There'll be 2 Mara baseboards that will be available, and you will be able to develop your own pitchlet, put it in, and you'll be able to interact between them, do all your tests, acceleration tests, whatever type of tests you want to do. And we are also looking at developing an accelerator application development, which is like a bare metal hypervisor converged storage device that we are actually planning to develop. But that'll actually be an ongoing process. Probably the mid of April is when we'll have that available. So that's what we're going to do moving forward. And in summary, you just saw the ODSA accelerator development platform is functional and it's all working right now. We are in the process of doing a rigorous hardware validation test to make sure that all the connectivity and everything we have done is working as per spec. And once they are all done, then we'll be actually deploying it at Supermicro Labs for remote access. Please stay tuned, and if you have any question and answers, or feel free to shoot. We're ready to answer. And if there are any recommendations, please let us know. If you need to, if you want to see some other new features, we'll be able to see if we can actually incorporate it moving forward. So that concludes our, presentation / live demo. So we'd like to open it up for any questions you have or any recommendations. That you're more than welcome. Even if you're not able to do it right now, please feel free to shoot us an email. Either with Bobby, JP, or me, Taman, we'll be able to address it and help you out. And if you need any assistance with developing the the pitchlets, we can actually give you all the files, base files to actually get you started, or we can even help you with the development process, whichever works best.
So if everyone could do me a favor and go off mute. Normally, if we'd be in a room, we'd all clap for JP and Vijay, because if you've been involved with the ODSA for a while, you'll know this is like a monumental achievement. This project has survived a whole bunch of participant changes, delays. It's JP has pushed it through thick and thin. We've got 7 active companies who push stuff into it. We're hoping for more. But it's a full, just done out in the open with on a shoestring budget. So if you could join me in giving JP and Vijay and everybody else involved a round of applause, Jawad. So thank you. It's a wonderful achievement.
Thank you, Vijay. Thank you very much.
Sam, I don't know whether you want to say anything as one of the founding partners.
I thought you said it well. Great achievement. It's good to see this up and running. I know we have, in a thing of this complexity, to have only one bus reversed is amazing. So
we're extraordinarily happy, and hopefully this will be put to good use as we move forward. And there's solid support from Facebook. Unfortunately, either Kevin or DJ couldn't be here. So awesome, thank you.
So Bobby, for the team, this is amazing.
Yes,
it's a sustained effort by JP and Tamin and everybody. The beauty of this project is it gives everyone a foundation to start on a chiplet-based program, because the same board can be used for architecture and can be used for the testing of the final product with chiplet-based design. So the principles are solid, and the beauty is everything is in the open.
Yep.
Yeah, Bobby, this is Archana. I just wanted to echo the same thing. I mean, this is the essence of Open Compute Project. And what we strive for in terms of collaboration, across companies, across even projects, because you guys are using, the PCI projects and storage, and it's across projects, it's across companies, it's across geographies, and this is a complete testament to what OCP also stands for. So thank you to everyone that has come together and supported this.
I'm glad you're here, Archana. I think that it exactly is everything you said. This has survived an incredible amount of change.
Yeah, I was going to say, I know it wasn't easy, and it was definitely, it's hard to, when you take off your corporate hats and try and come together, because you are facing some challenges, both internally and externally, but this is exactly what OCP stands for. So thank you.
Yeah, it does. Yeah, JP's got an incredible talent. I think he got 3M, Molex, an extraordinary number of companies to put stuff in. So very nice. JP, anything you want to add?
Yeah, Bobby.
I have a comment. Oh, sorry. Go ahead.
Yeah,
go ahead, please.
Go ahead.
I mean, I just want to say that this is really impressive and really great. I think the next step, right, is the application development, and I'd like to, ask the end user work group to make sure that they, send some people over to remote access this and develop on it. So if we're going to prove out a market for this, now we need to develop an application on here that has value, right, that someone wants to pay for, the whole system. So that's really a very, very important next step. And I want to, there's a call to action, I think, for the end user group to use it and figure out, how they would use it in a commercial sense.
Very good point, Ali.
Yeah, thank you, Ali. Thank you, Bobby. Bobby, we want to thank mainly for all your support, and Jawad and everyone, the team for. This project has been going on for about more than a year now, and it's good to see all coming together. And thank you, Vijay and Shakti Chairman. And I also want to thank particularly the extraordinary support we received from Facebook thermal and mechanical teams. There are, even though we're demonstrating most of electronics here, a lot of thermal work has been done on this project to validate all the configuration that we want to test. And same with mechanical. This we wanted to have a very good, robust mechanical fixture for this. And Facebook team Chenyu did excellent work on this to put together a fixture for the mechanicals. And also thank Astra Labs for providing the support with the retimer. They are a startup company, but they give us a lot of support in bringing up the platform with the retimer. And same with 3M. The 3M actually sponsored all this PCI Gen 4 cables and designed for us. Right, and same with the Molex and Amphenol. And they did a lot of simulations for us to validate this platform, as particularly signal integrity simulations with their connectors. And ANSYS did a very good work on us to get started the platform again with signal integrity simulations. And a lot of companies involved over time, and that's where we could get where we are now. And I'm pretty excited for the hyperconverged storage node platform that we're developing, and that's all developed in open source and available like a cloud model for anyone to get access to that platform. It's pretty exciting. I'm great looking forward for the next 4 months where we'll have this application demoed. Yeah, thank you, Bobby. That's all I'm saying.
Excellent. Hey, Archana, if possible, I think it'd be great if we could get some publicity to the OCP blog for this effort. Like you said, I think it represents the best of OCP. So to recognize the milestone.
Happy to do it. I just need someone to help me write the blog, or if someone wants to write the blog, we will broadcast it across social media. It would be great if we could have a picture of the board as well, so that we could, people see it. And yeah, happy to do it.
Excellent.
Again.
Excellent.
Yep.
Thank you.
Mm-hmm.
AP?
Yeah.
Between us, I think we should be able to pull this off.
Sure, definitely. Yeah, I'll be happy to.
Excellent. Okay. Thanks again. So on to the next item, which is pretty exciting as well. Jawad and David from CDX are going to have are planning a white paper. So David, all yours.
All right, thank you, Bobby. Can you hear me okay? Do you guys hear me okay?
Give me one second. No, we can't see your screen.
Okay, give me 1 second. Apparently, you know what? I need to configure something here to allow sharing. So I don't know if you want to share or.
You want me to download and share? Give me 1 second. Okay.
Yeah.
Give me 1 second. Okay.
I have the most. Yeah, I can't share right now.
Well, that's okay. I know that GoToMeeting has been having some issues, folks. They have updated it, and those that are using the Big Sur platform on their Macs are having some issues. So if you do have that issue, the guidance that we have received from GoToMeeting is to use Safari. Apparently Safari is working, but Chrome is not, and they're working on an update to make it happen. So if you guys run into this in any other way, yeah, the suggestion is to use Chrome, to use Safari.
Okay. All right, thank you for the update. I think in this case, it was just my paranoid security settings. It wouldn't allow me to share. That said, at CDX, we have started working on a white paper. Basically, the work we had done last year involves some of the workflow. How do we get chiplets integrated together? And we had done some work that's related to power and thermal, and the intent is to summarize all of that into a white paper. On the right side, in the right column, you can see what the overall outline of the paper is. There's actually more details into the actual white paper. So what we are looking for is volunteers to help us to complete this white paper. We have some participants already, but we definitely would benefit from having more inputs on these topics. Specifically, right, the charter of CDX is the data exchange to allow integration of chiplets, and what are the workflows around that. So if you have input, please come on Tuesday and help us out. Definitely we would benefit from your input. I think that's about all I have, actually.
Well,
I can.
Yeah, go ahead, Jawad, please.
Yep.
So the overall outline of this white paper basically captures the pain points of a early stage architect who has to make design choices and has to come up with the whole project management of a chiplet-based solution. So that all starts with how do you model these chiplets? How do you choose a packaging technology? Think about the power estimation of multi-die solutions. How do you think about the thermal solutions? And then it leads into, okay, will power integrity be fine here? What will be the signal integrity issues? And what are the workflows for it? And towards the end, how do you actually produce this and do a system level test for that the yield is reasonable? So it's a pretty wide scope, though we are trying to limit it primarily around the workflows. And we have been working by using an example system, and various companies have worked on different aspects of that example system. So we have some gaps on the architecture side, on the signal integrity, power integrity. If you are willing to make, I think, contributions or participate with a little bit more time into it, this will be an excellent opportunity to not only get some PR for your company and your background, because we will give credit to everyone who participates, and we are open to mentioning commercial workflows in there. So if you have time, that would be an awesome help for us in CDX, and I think you will hopefully will like participating. So hence we decided to come here on Friday morning and ask for more participation.
Yeah, by way of intro, when we just before we did the ODSA, we had this good white paper from 10 or 12 companies, and that really helped us sort of formulate what we should do in the ODSA. I think we're hoping that this white paper will be something along the same lines for information flow. Ravi, I volunteered you for something. I don't know what exactly, but I volunteered you for some role in this.
Sure. Actually, I was also wondering, I would like to take part in this, so maybe I'll just connect offline.
Yeah. So the idea is to sort of capture the state of the art and recommendations for best practices, etc. So
sure.
Yeah. So if anybody else, if you have a vested interest in this, please feel free to please participate.
I have a question for Jawad. In each of these sections, Jawad, is there a definition of what kind of inputs you need in terms of from a chiplet vendor in terms of what is the model that is required for effectively analyzing each of these?
So that's a great question, Suresh. So in chapter 3, in a way, would talk about different modeling components that would, generally include things that you need to do the layout, but more importantly, electrical design and testability and behavioral design. So in particular, on the behavioral side of things, it's a bit of a ill-defined ecosystem right now. So yes, then each section will kind of like connect back with it.
And I forgot the one thing we're aiming for is the global summit. Roughly, usually these things take about a quarter. So the intent is to get this in shipshape by the March global summit.
So Bobby, small change there. Not sure if you caught it during Tech Week, but the global summit has actually been pushed back to October, November in 2021. So
we have nothing in March?
We don't have anything specifically planned in March, but that does not mean that we cannot plan something in March. So we are keeping March open right now, March, April, and there have been other projects that have asked for not like a week-long tech week because they felt that that was almost too intense, but to kind of scatter workshops, day-long workshops, so that we can get a lot more cross-pollination across all of the other projects. So there is something targeted for the March, April, May timeframe, but it will be ODSA specific, and we can happily do that. So I don't want so much time to go between, Tech Week and October of next year, because that would not be good. But we're planning a series. It might just not be all glommed together like we did for Tech Week. You know what I'm saying? To just kind of scatter it a little bit. So definitely plan for something in March, but it won't be the global summit that you're talking about.
Is there something for Asia and Europe?
Well, and that is up to you. So we could do it at a time that meets Asia as well as Europe. We're totally flexible as to how and when and how long duration you want to do this this workshop.
Hey,
Okay.
Bill. I volunteered you or the HIR for chapter 9.
Okay, anytime you volunteer, I am okay.
Okay.
Just don't make it 1 a.m. in the morning.
No, at least for that chapter, I figured it's already in flight anyway, so that we should just leverage what's going on rather than reinvent the wheel.
Yeah, thank you. Volunteer me is all fine.
All right. Okay, so Jawad and David, we just had to hunt for a few more. Rita was online, but she logged off, and then Javi from ARM. Those are the guys we need to chase down. Anybody else want to interested? Please reach out to either me or David or Jawad, preferably David or Jawad. Okay. Then let me see. Yes. Okay, Suresh. Then, in terms of future, I was thinking that we should do, since we hopefully in the month of December we do our test chip proposal and planning, that we should roll it out on the 8th, first thing in the new year.
Sure.
We're still, so the last open item is for 2 minutes. Well, first off, does anybody have any opens? Maybe I'll start there. I can do the list of speakers. We've got time. So Alan, Jawad, any opens? David, JP?
I'm good, Bobby. Thank you.
Raviano, any opens?
Not from my side, Bapi.
Not here. Thanks.
Myron Paul. Okay, Suresh Ali. Oh, yes, go ahead. I want to tell everyone that the business group is meeting at 9 on the same bridge. So if you want to stay back, now's a great opportunity.
Yeah, I just wanted, next week I'll be talking about that reference, like kind of platform architecture proposal, try to put a little bit more detail around it, and we could have some time to talk about it.
Excellent.
So one question on that, Ali. Are you looking at things like the OCP NIC or OAM as kind of platforms on which you could build these chiplet integrations? Or
I mean, the OAM is more board level, right? So if we're talking about taking something that would maybe be an OAM and how much of it do you package inside and how much you package outside, right?
Right.
I think, I mean, that's where we're at anyway. I don't see that as really something different than what we're already doing. Does that make sense?
Yeah. In terms of how it fits into the overall OCP ecosystem, that's what I was alluding to.
I see. Well, maybe we can talk about it if you're sticking around for the business group meeting next. We can discuss it there.
Okay.
Sorry, I just caught the tail end of that, but regarding the OEM, I think that is an interesting topic of how do we blend, or how does the OEM leverage some of the output from this? Is some of the big OEM modules, it may use a chiplet approach. So various system level aspects that come to mind for me.
Okay. Shreyas Tawfiq.
Nothing on my side. Nothing from my side, Bapi.
Okay, thanks, Shreyas. Philip Sam. Gus Scott.
Sorry, nothing on my side.
Okay.
Nothing from me.
Gus and Scott.
Nothing, thanks.
Okay. Elko Bill.
I'm fine.
Okay.
I'm good too, thanks.
Okay, Archana, you don't count. So Bill and Rob.
Good, thanks.
Okay. Who did I miss at the bottom? Vijay, and I can't see the name at the bottom. So one last thing. Yeah, go ahead, Vijay. Sorry.
No, we are good, JP. Thank you.
All right.
Bapi, sorry, I keep saying JP. Sorry.
Don't worry about it. It's an honor.
Sorry for that. Yeah.
One last thing, Kevin isn't here today, but man, he was instrumental in moving the POC along at critical moments. So a huge thank you to him too. His was the one name we didn't say thank you to, Kevin at Facebook, and trust them to miss today's meeting, Kevin and DJ. So on that bright note, thank you all. Enjoy your weekend. Stay online. I think we'll just leave the bridge open, right, Archana and Ravi, and I just won't record it. And stay online if you can participate in the business meeting. So we can definitely use all your help. But I'm going to stop recording this session.
Yeah, we can just leave this bridge open.
This conference will now be recorded.